Got an interesting set of simultaneous equations here, and we're given some guidance on how to solve them. We're going to be using the identity at the top to rewrite the expression on the left. So I'm going to deal with the right-hand side. First up, just some preliminary work. Let's work out what x minus y plus 2 squared is. And I'm going to get x squared. Then we're going to get minus xy, but I'll get another one there. So I'll get minus 2xy. Of course, do it term by term if you prefer. And then 2x and another 2x, so 4x. That's all the x's, and I dealt with a few other terms as well. And then minus y times minus y is going to give me plus y squared. We're going to get minus 2y there, and also from there, so minus 4y. And the only term I've not dealt with is the 2 times 2, so plus 4. And that is simplified. Then for cx plus y all squared, that's a little bit easier to expand. We can just leave it like this. It's going to be c squared x squared plus 2c xy plus y squared. And therefore, let me call this identity star. The right-hand side of star is going to be identical to, I just take the first one and multiply all the terms through by a. So ax squared minus 2axy and so on. And then add the second one, but multiply all the terms by b. So bc squared x squared plus 2bcxy plus by squared, and then plus d. Now, before I bring in the left-hand side, let me just collect the terms together and try to write it in this order. So x squared terms, I've got ax squared, and I've got bc squared x squared. So I can factorize out the x squared, like so. Next up, it's the y squared term. Got ay squared plus by squared. So a plus b y squared. Then it's the xy. So I've got 2bcxy, but then I'm minusing 2axy. That doesn't leave much, that just leaves plus 4ax minus 4ay plus 4a plus d. Those are the constant terms. And this is identical. Now I can bring in the numbers. So it's the same thing as here. 5x squared plus 2y squared minus 6xy plus 4x minus 4y. Now this is an identity. It means it's true for all values of x and all values of y. And what follows is that we can equate the coefficients. It must be, so equating coefficients must be that a plus bc squared is equal to 5. And then we'll do the same with all the other ones. A plus b is going to equal 2. Two bc minus 2a is equal to minus 6. 4a is equal to 4. Minus 4a is equal to minus 4. Actually, that doesn't give us a new equation. It's the same one. And then 4a plus d is equal to 0, in fact, because there is no constant term on that right-hand side. Okay, let's solve them. Let's start with the simplest one. Actually, this works out really nicely. We can start with this one. A is going to equal 1. If I then substitute that in to the bottom one, then d, so 4 plus d is 0, d is going to equal minus 4. Next, I'll put it into the second one. So b is also going to equal 1. And then finally, if I put it into this one, there's a bit more work to do. Take it steady. It's going to be 2 times 1 times c, so 2c, minus 2 times 1 is equal to minus 6. Therefore, 2c is equal to minus 4, c is equal to minus 2. And as a final check, let me just substitute into this one to see that I get 5 on the right hand side. So 1, and then b was 1, so 1 plus 1 times minus 2 squared does equal 5. So this checks out, and we've managed to find the right values. So I think just finally, let's write it in that form, because that's going to come back in, I think, later on. So a was 1, so we're just going to get x minus y plus 2 all squared. B was also 1. C was minus 2, so we get y minus 2x squared minus 4. Now the question then asks us to solve these simultaneous equations, but what we're going to have to do is do exactly the same thing for this expression, because then they'll be in similar form, and hopefully it's going to all work out. So we don't need, we've already expanded that the starting thing that we're trying. So I've got it all nicely lined up so we can equate coefficients. So it's going to be slightly different this time. So a plus b c squared is going to equal 6. A plus b is equal to 3. 2bc minus 2a is equal to minus 8. 4a is equal to 8 minus 4a is minus 8. And then again, 4a plus d is going to equal 0. So this time a is 2, which means b is going to equal 1. D is going to equal minus 8. And here we're going to get 2c minus 4 is equal to minus 8. So 2c is minus 4, c is minus 2. Just check back, because this is a nice little safety mechanism for if we've made a mistake. 2 plus 1 times minus 2 squared is in fact equal to 6. So it's all good. And that means that 6x squared plus 3y squared minus 8xy plus 8x minus 8y is going to be identical to 2x minus y plus 2 squared plus 1 times y minus 2x squared minus 8. Right, I am ready to solve these simultaneous equations then. We had the 5x squared one was equal to 9. So I'm going to write it as x minus y plus 2 squared plus y minus 2x all squared minus 4 is equal to 9. And then this other one that I've just obtained, 2x minus y plus 2 squared plus y minus 2x all squared minus 8, that is equal to 14. This is actually just like your normal simultaneous equations that you first learned about with x and y. It's just that instead of x, we've got this thing, actually the whole thing squared. And instead of y, we got this thing. You could do a substitution. And actually, I think I'm going to do that. So this here is going to be v, and this here is going to be w. So then I get v minus w is equal to 13 because I've added 4 to both sides, and 2v plus w is equal to 22. Sorry, that was a plus as well. I don't know why I said that was a minus. What I'm going to do first of all is just swap them round and subtract them. So v is equal to 9. We can then substitute back in, or we could, so I'm just thinking, or we could times it by 2 and then add them, but actually subbing back in is much simpler. We're going to get w is equal to 4 just by, replacing it there. Okay, well that's good. You know what, when I did it, I think I ended up making it more complicated. Let's just not forget then that we've got y minus 2x all squared. That's my w, that's equal to 4. And then x minus y plus 2 all squared is equal to 9. So I've got a bit more work to do to get our values of x and y. Y minus 2x is going to equal 2 or minus 2. And then x minus y plus 2 is going to equal 3, or it's going to equal minus 3. And I need to take these together one at a time. So case 1, let's have y minus 2x equals 2, and x minus y plus 2 equals 3. So that is going to mean that x minus y is 1. I can write this as minus 2x plus y is equal to 2. I can add them together to give me minus x equals 3. So x equals minus 3, y equals minus 4 is going to be my first solution. Now let's take the y minus 2x again, equals 2, but put it together with the other one. So x minus y plus 2 is equal to minus 3. So that means this time we get minus 2x plus y is 2 again, but it's going to be x minus y is minus 5. Add them together. Minus x equals minus 3. So x equals 3. Put it back in, y must equal minus 8. And just check back, that. Wait, does that work? X is 3, minus 6, yes. No, I think I've made a mistake. Oh, sorry, y is going to equal 8. There's minus 6 plus 8 is 2, and 3 minus 8 is minus 5. Apologies there. That was case 2. Case 3. Let's now go to y minus 2x is minus 2. Return to x minus y plus 2 equaling 3. Add them, minus x equals minus 1, x equals 1. And I think that means y is going to equal 0, because it checks out in both equations. finally, y minus 2x is still minus 2, but now x minus y plus 2 is going to equal minus 3. Minus x equals minus 7, x equals 7, and sub that back into this one. We're going to get 7 plus 2, so 9 minus y is equal to minus 3. That means y is going to equal 9 plus 3. Y is going to equal 12. Let's just check it in this one. 12 minus 14 is minus 2. So there we go. We had to think about all these different cases, but we've not, they're all going to be solutions. It's not like we've squared at any point, which you can get spurious solutions for. And you could substitute it back into the original if you wanted to, but it will all check out. It's absolutely fine. We've managed to rewrite this into this thing on the right, being given some guidance for that. We did it with the second one, and suddenly we had simultaneous equations that didn't look anywhere near as bad. We solved them. We called them V and W, found the solutions pretty quickly, substitute it back in. You get a pair of solutions for each. We just then had to match them up. So actually we had 4 different solutions, and that is it. Let me just say, so if you were to sketch or plot these graphs, not expected to sketch them, then what you actually get is 2 ellipses. It ends up looking a bit like this. Sorry, this is not sort of just, it's not actually drawn accurately or anything, but yeah, you get solution here, 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 and here. Well done.